Hello everyone, welcome back to the channel. Today I'm going to conduct an experiment to prove the AND gate truth table. So there will be two experiments where I'm going to use Circuit.js simulator. In the simulator there are built-in logic gates. So the first experiment will be using these logic gates to prove the truth table of AND gate, and we will be making AND gate using transistors. So we have two experiments lined up for this video. Without further ado, let's get into it. So my Circuit.js simulator is already running right now. So let's create a new blank circuit as we always do before doing any kind of experiments. So now I have already seen through the AND gate truth table on the internet. If you guys are interested on to having a look for it, I will put the link in the description box below. So the truth table for the AND gate goes as so guys, let's just make a truth table first of all. So I'll just put a text and copy and paste it like we have A, B, and we have the output as C. We have four cases and two inputs. So as we have the input as A, input as B, output as O, case 1, case 2, case 3, case 4. So let me just distribute this properly. So in case 1, if we give the input as 0 and 0, we should get an output as 0 because AND gate is basically a multiplication of two values. So if you multiply 0 by 0, you get an output as 0, right? And if you have A as 0, B as 1, still you'll get the output as 0. And in third case, if you give an output as 1 and the other output as 0, still 1 multiplied by 0 is still 0. And in the final case, if you give 1 multiplied by 1, you get the output as 1. So let me just rearrange everything properly before we start doing the experiments. I guess this is pretty much fine. Let me increase the size. Okay, so for the first experiment, let me just put the text. For the first experiment, we will be using the built-in logic gate in the simulator, right? The built-in gates. So for that, right click and look for the logic gate, input, output, and everything. We need AND gate, and now we have an AND gate over here. So this is the symbolic form of an AND gate. We have two inputs and one output. Okay, so now I will be adding logic input. Okay, 1, 2, and I'll be adding a logic output over here. Okay, this is the text for these A, B, and O. Okay, so let's just follow the cases and let's cross verify if we are getting the output as we have written on the truth table. Okay, in case 1, if we give, let me just edit this so it's in numeric form. Okay, now in case 1, if we give the input 0, A 0 and B 0, we get an output O as 0, as we have already proven the first case, correct? In case 2, if we give A as 0, A is already 0, and B as 1, so we'll turn this one 1, we get an output as 0. So as you can see, the output is 0. Now in case 3, if we give A as 1, A is 1 and B is 0, we get an output as 0. O is 0. So we have proven first three cases correct. And in case 4, if we give A as 1, A is already 1 and B as 1. So if we give both the input as 1, we get an output as 1. So basically it is a multiplication of two numbers. Multiplication of two numbers, you get the output as such. So we are multiplying the binary numbers. Okay, so if you multiply 1 by 0, it will give you 0. If you multiply 0 by 1, it will give you 0. If you multiply 0 by 0, it's definitely 0. Only if you multiply by 1, then you get an output as 1. So hence we have already proven using the logic gate symbol built into this simulator. Now let's build a AND gate using a transistor. So for that we will write down experiment number 2. Wait, experiment number 2. For this, what I will need is transistor of but obvious, and we will need resistors. If you have seen my previous video where I was making a NOT gate, we only required only one transistor for it, but for this one we will need 3 transistors. So once you go right click, go into active component, we need a bipolar NPN transistor. 1 2 3. Okay, let me just try and keep, sorry. Now let's first of all wire these up, then I'll show you where to add the resistors. So to wire up, wire. Okay, now we need to add resistors. One resistor over here, one resistor over here. We need to give an resistor at the input for both. Now let's add wire. Let's connect this, so we will connect these two together. This one goes here, this one goes here, and we need to add input source. Add input source as ground, and add input source voltage source as plus 5 volt. Okay, now we need to give two logic inputs. Okay, so add logic input low, and let's edit this numeric, and we need to add one more ground, or we can just wire these ones up. Okay, now we need to add a logic output at this point. So if you see, we have 3 transistors. So for this one we are connecting the output to the collector of this transistor, the third one. The first transistor will be this one. Okay, the collector of the first transistor connected to the base of the third transistor, and the collector of the second transistor is connected to the emitter of the second transistor. So if you guys want, I have already given the link for the schematic into the description box below. If you guys want to refer the schematic properly and want to read more about it, you can just feel free to go onto that website and have a look onto it. So let's begin. Let me just, so we have a input, B input, and we have an output as well now. So let's start with proving the case for of AND gate truth table now. So first case, input A as 0, input B as 0, you get an output O as 0. Okay. Case 2, input A as 0 and input B as 1, you still get an output O as 0. Now in third case, we get give an input A as 1, input B as 0, we still get the output O as 0. Now if we give, in case 4, if we give an input A as 1, input B as 1, you get an output O as 1. Okay, so guys, this is the basic experiment, okay, to prove the truth table. So if you are thinking about why to make a transistor based logic gate, so basically this is just a representation of a complex circuit like this. So whenever we are using or making a schematic, we will be usually using this instead of this one. I hope you guys understood the procedure of this experiment for proving the truth table of an AND gate. So both the experiments we used, for both the experiment we used AND gate basically. The first experiment we used the logic gate symbol, which was built into the simulator, right? And in the experiment 2, we made our own logic gate using the transistor. So if you guys have any questions, make sure to drop a comment in the comment section below. So guys, please make sure to subscribe to the channel and turn on the notification bell, so whenever I drop a experimental video, you'll get to know. Till then, see you guys. Bye bye.